Hey everybody, Chris Bryant here, and today for my CCNA and CCENT Bulldogs in particular, but some good stuff for you CCNPers as well, got a video lab called The List. Sounds pretty ominous to me. We're going to jump in right away, and I want to show you the diagram of the lab that we're using first. Might want to jot these IP addresses down. Got a couple of routers connected via a switch, and you can see they're using their fast Ethernet 0/0 interfaces. Router 1's on 10.1.1/24, router 2 at 10.1.1.2/24. I've also got a couple of hosts connected to router 2 at the 10.2.1.2 and 10.3.1.2 IP addresses respectively. And I have a default static route on router 1 that hopefully will allow router 1 to ping both of those devices right now. So as always, when we start a lab, you definitely want to test things before you start adding things. So let's do a quick ping on 10.2.1.2 and 10.3.1.2, and those are the addresses in question, and right now they're not in question. Router 1 can ping them both without a problem. And you're saying, well, that's perfectly fine, Chris, but what about the list? Well, here is that list, a couple of them actually. And I already have these written on router 2. I haven't applied list 105 yet, because first off I need you to tell me if I'm doing it correctly. We've got two access lists on the board. Access list 5, access list 105, and then on the fast Ethernet interface we have our IP address that of course we expect, and IP address group 105N. First off I need to know from you, is that the correct way to apply list 105? Does the presence of list 5 matter at all? Yeah, that's a good thing to know, because you might run into a router, you got one applied, and you got 6 ACLs written. And let's see, what I really want to know, if this is the correct way to apply the address, what is the net effect going to be? Is router 1 still going to be able to ping both of the addresses it just pinged? Is it going to be able to ping none of them, or one in particular? It's good stuff to know. You definitely got to know your syntax and everything to go along with your ACLs and your application, and we're going to see it live in just a moment. I don't put ads in my videos except for my stuff. Forgive me. Very quick plug. Over 100,000 students are in my Udemy video boot camps right now, and my CCNA course is #1 on that list, and right now you can join for 19 bucks. I'm going to put the link here in the YouTube description. You can also use the coupon code 19YouTube, no capital letters, no spaces, just 19YouTube, as easy as can be, and 30 hours of my world-class CCNA video bootcamp training, the most popular CCNA course on Udemy, and you get in for 19 bucks. One heck of a deal. So let's go ahead and head over and bring up the live equipment first of all. And before I do that, very quickly, on that IP access group, this is the correct way to apply an ACL. It's not enough to know how to write an ACL, and Lord knows for the CCNA and the CCENT you got to be all over ACLs. But what you also got to do is know how to apply them correctly. And when you're applying one to a physical interface, the command is IP access group, and then the number, and then the direction. And actually I'll use iOS help along the way on that, because a couple of very important details here. And we will start with IP and its access group. Then you're going to be asked for the number or the name of the ACL. And mine was 105, and that is an extended ACL, right? So that comes into play here in the question as well. Then you have to say whether I'm applying them for inbound traffic or for outbound traffic. There is no both option. It's rare that you're going to take the same ACL and apply it for inbound and outbound traffic on the same interface. Very, very rare that you're going to do that. You might put a mirror image, kind of a backwards image, if you will, of it, but you're not going to apply the exact same ACL very often. Also notice that this is not an option. You have to put in or out. There is no CR there. So we will go ahead and filter inbound packets. And that's it. So now we have successfully applied that. Let's go back and look at this particular syntax of that extended ACL, because that's good stuff to know. Access list 105, then we have deny IP host 10.1.1.1, host 10.2.1.2. Well, with our extended ACLs, the deal is that we have to define a source and destination IP address. So here we're using the word host, which means this particular IP address only. So with access list 105, deny IP, and then host 10.1.1.1, what is that host 10.1.1.1 referring to? See, I'm hitting you with all kinds of questions today. Host 10.1.1.1 refers to the source IP address. Host 10.2.1.2 refers to the destination address. Now, an answer begets another question. What happens if only one of these two criteria are met? And what happens is the line does not take effect. So for this first line of the ACL 105 deny IP host 10.1.1.1 host 10.2.1.2, it has to have a source IP address of 10.1.1.1, the traffic does, and a destination of 10.2.1.2. Otherwise, we're going to drop to the next line, which in this case is access list 105 permit IP any. And what does that mean? That permits everything. We have to put that there. Why? Because of the implicit deny. So all kinds of things going on here with just a two-line ACL. So now that we've applied it, let's go over to router 1 and see what happens with our pings. First, we're going to send one to 10.2.1.2. That is the one that was explicitly mentioned in the ACL. And we got a pretty wild response here. U.U.U. Not something we see terribly often. We've seen it in another certain scenario in some of my other videos. But here we're seeing it because the packets are leaving successfully. They're leaving router 1. But they're getting to router 2, and router 2 is saying, get out of here. Because that traffic matches both parts of ACL 105, the first line of it. It matches the source destination of 10.1.1.1, and it matches the destination address of 10.2.1.2. So it's being denied. Now the traffic for 10.3.1.2, what's going to happen there? Well, it doesn't match the first line of ACL 105. It matches the source address, but not the destination. So it's going to drop to the second line of the ACL, which permits everything. So if the theory holds, that means that this traffic should indeed go through. Ta-da! And it does just that. So great stuff here for your ACLs and your extended ACLs. And by the way, it didn't matter that there was an ACL 5 here. That's a little bit of a red herring. You can have ACLs written on the router that aren't applied, and they're not really going to affect the ones that you have applied. So here again, with IP access group 105N, we're filtering inbound packets on router 2. The packets that match both source and destination of the first line of line 105 were denied, and then the other packets, the ones that didn't match that line, were permitted by the second line, permit IP any. That concludes today's longer video boot camp. Hope you enjoyed it. We're definitely going to be running some longer ones here because I know from watching our statistics and reading our email, those are the ones you like. So we will be back tomorrow with a new one and a practice exam as well. I'm Chris Bryant. I'll see you then.